In the introduction to differentiation video, we looked at first principles and how we use first principles to differentiate functions. In this video, I will be using first principles to differentiate cos x and sin x as an extension to that video. So starting off with cos x. From the last video, we know how to use first principles. So we know that first thing we find or we identify our function, then we add a small change to x. Afterwards, we subtract our function from that function and divide that by a small change in x, and then we find the limit of that function as delta x approach 0. So let's do that with cos x. F of x is our function, which is our first step. We identify that our function is cos x. Afterwards, we add a small change to x. So cos x plus delta x. After this, we subtract cos x from what we have here and divide that by the small change in x. So we have f of x plus delta x minus f of x. All of this is over small change in x. So we'd have cos x plus delta x minus cos x. We divide all of that by delta x. Now we want to simplify what's in our numerator. Here we have a cos function subtracting a cos function. We are going to use what is called the cos minus cos formula. The cos minus cos formula looks like this. This is a little bit blurry, but this is what it looks like. Here we have a cos function and a cos function, and they're subtracting. So we are going to replace what we have in our numerator, which is this, by this here. So we're going to have negative 2 times sine what's in our first function plus what's in our second function divided by 2, and we're going to do the same thing in our next sine function except we're subtracting. So let's do that. So we're going to have this negative 2 sine. Remember, we're adding this to what we have in our first function. So x plus delta x, and we're going to add what's in our second function, which is x, and we're going to divide that by 2, times sine of x plus delta x minus x over 2. And all of this is over delta x. If we look here, this cancels this, and x plus x is equal to 2x. So let's put those in. Now this is what we have. We can rewrite what we have here as this. Since we are multiplying this by this by this, we can apply this to just this function here because all three are being multiplied. So this is basically 3 times 4 times 3. So we basically have 4 times 3 times 3. So let's do that. And we're going to leave the negative sign in front. And that's what we have. Since sine is an odd function, we could take out what's inside here and we could put it outside. And we are going to do the reverse of that and put this on the inside of this function. So we will have this. Now all of this is equal to 1. So we are going to have, at this stage, we're going to find the limit, which is step 4 of first principles. So we're going to find the limit of this. And all of what we have here is this. So we're going to find the limit of what's here. So the limit of negative sine 2x plus delta x over 2 times sine 1 as delta x approaches 0. If you recall from limits, a limits theorem says if you have the limit of a times b as x approaches a point a, where a and b are functions of x, then we can rewrite this as the limit of a times the limit of b as both limits approach the same point a. So that's what we're going to apply to what we have here. The limit of negative sine 2x plus delta x over 2 as delta x approaches 0 times the limit of sine 1 as delta x approaches 0. For the first function, if we directly substitute 0 for delta x, we will have negative sine 2x plus 0 over 2. For our second function, which is this, sine 1, we can rewrite sine 1 as, we can rewrite all of this here as the limit of sine 1 over 1 delta, as delta x approaches 0. And we learned that sine of whatever over the same thing is equal to 1. So the limit of this is equal to 1. So let's put that there, and remember it's being multiplied. So if we go ahead and simplify all of what we have here, we will result in negative sine x. And that is because this 2 cancels this, and there's just a 0 there, and that's being multiplied by 1. So our final answer is equal to negative sine x. And that is indeed the derivative of cos x. The derivative of cos x, if you remember from the derivative table I showed you, the derivative of cos x is equal to negative sine x. Now let's look at sine x. As before, we identify our function. Our function is equal to sine x. Our next step is to add a small change to x. So f of x plus that small change is equal to sine x plus that small change. The next step is to subtract sine x from what we have here and divide it by the small change in x. So f of x plus delta x minus f of x over delta x is equal to sine x plus delta x minus sine x over delta x. Now we need to simplify as before what's in our numerator. And as I said, we could do this two ways. The first way we used what's called the cos minus cos formula, or sine minus sine, or sine plus sine. It's basically this: cos plus or minus cos formula, or sine plus or minus sine formula. I'm not really sure of the name, but this is what I call them. So we use this in the last example. What we're going to use in this example, however, we're going to expand what's in sine. So if you did trigonometry, you would recall that sine A plus B is equal to sine A cos B plus sine B cos A. In our example, this would be our A and this would be our B. So we are going to apply this to this section of the numerator. So let's do that. So we'll have sine A, which is our x, cos B, which is delta x, plus sine B, which is delta x, times cos A, which is x. And remember, we are subtracting sine x. So minus sine x. And all of this is being divided by delta x. What I have in the red parentheses is what I replaced all of this with. Now I can rewrite this as sine x cos delta x minus 1 plus sine delta x cos x. All of this is over delta x. Now we want to find the limit of this. So the limit of sine x cos delta x minus 1 plus sine delta x cos x over delta x as delta x approaches 0. This is equal to the limit of sine x times cos delta x minus 1 over delta x plus sine delta x over delta x times cos x as delta x approaches 0. If we apply the same principle where we can find the limit of each function here individually, where we find the limit of this function, the limit of this function, and we multiply them, then we find the limit of this function and multiply them, and afterwards we add them, we will result in this. The limit of sine x as delta x approach 0 would have sine x. For this section, when we plug 0 here, we will get 1 minus 1. So we'd have 1 minus 1, and when we plug 0 there, we'd have 0. For this section, we will get a 1 because we have sine delta x over delta x as delta x approach 0. So we would have a 1. And for this function, we will just have cos x. Now when we complete this, we will have 0 times sine x plus 1 times cos x. This 0 here times this sine x will give 0, plus this 1 times this cos x will give us cos x. So our final answer is cos x. And this says that the limit of sine x is equal to cos x, which is indeed the correct answer. So from this video, we learned that we can use first principles to differentiate sine x and cos x. For cos x, which was our first example, we got negative sine x. And for sine x, we got what we see here, cos x. And this is how you use first principles to differentiate. This will be the last video on first principles, so I hope you got it. Thank you for watching.